Hello and namaste. My name is Brandon, and welcome to the next video in my series on basic time series. In this video, we will learn about another forecast accuracy measure called the mean absolute percentage error, or MAPE for short. And as always, please like, comment, and subscribe. Let's get started. So these first few slides I will go through very quickly because they are the same as the previous videos in this playlist. So the data set we are looking at is the GDP per capita for Nigeria from the year 2000 all the way up to the year 2020. And what we're trying to do is generate a forecast for the year 2021, in this case using the naive forecast method. So the naive forecast method is very basic. We're just taking the value of the previous period and that becomes the forecast for the next period. So basically we are shifting the entire time series forward one period into the future, and that becomes our naive forecast. So you can see how this works. Now the forecast error, as you can see in the right-hand column there in the yellow and blue, has a sign. So we can see that the first 2/3 of the forecast errors are positive, and then the last third of the forecast errors are negative. Again, this is based off the naive forecast. We always want to examine our forecast errors graphically. So here are the forecast errors in graph form from the previous chart. So we can see that the first 2/3 are positive in terms of their sign. And then we can see that the last third or so are negative. So for the first part of the time series, the actual values are above the forecast values from the naive forecast. And then the last third or so are the actual values are below the forecast values using the naive forecast. So always know your errors. Forecast errors create a new derivative time series that can be a treasure trove of information for the analyst. By looking at just the naive forecast errors, you should be able to reverse engineer how the underlying time series looks, again, just using the forecast errors. In fact, many forecasting techniques do this very thing under the hood. So patterns in the naive forecast errors can reveal trend, seasonality, inflection points in the time series, and so on. Examining naive forecast errors can also help in the selection and interpretation of more advanced forecasting techniques. So often the naive forecast is sort of a baseline forecast, which can inform future analytic decisions. So here is a graph of the GDP per capita for Nigeria over that 20-year period. There in the green line. The forecast value is just a mirror of that, shifted over to the right into the future, one time period. So we can see that a series of positive naive forecast errors, which are under forecasts, indicates an upward trend in the series because the forecast cannot keep up with the trend, therefore there's a gap between the two. Conversely, a series of negative naive forecast errors, or under forecasts, indicates a downward trend in the series because as the time series go forward, the naive forecast can't keep up with the downward trend. So we can use that information to tell, in this case, trend, an inflection point around year 16 or 17, and then how far apart they are. So the topic of this video is the mean absolute percentage error, or MAPE, which is one of many forecast accuracy measures. So MAPE, or M-A-P-E, is the mean of the absolute percentage errors. So we make a forecast for each period, find the forecast error for each period, which is the actual minus the forecast, calculate the percentage error by dividing the forecast error by the actual value, and that will give you a decimal value, multiply by 100, which will turn it into a percentage value. Take the absolute value of each percentage error, sum the absolute percentage errors, and 6, divide by the number of forecast errors or observations. That's just taking the mean. Important note here, MAPE makes comparisons of forecasting methods easier and more useful because working with percentages sort of standardizes the errors. So remember, in previous forecast accuracy measures we did in this playlist, we were using the original units of the time series. In this case, it's dollars, but it could be almost anything. Therefore, the forecast errors and therefore the forecast accuracy measures are influenced or determined by those initial units. However, using percentages alleviates that issue. So the time series original units no longer matter. Keep in mind, though, that the real implications of the error may or may not be meaningful. So here is our table again. In the final column, we have APE, which is absolute percentage error. Now, how do we calculate that? Well, it looks like this. Now, this formula looks a lot worse than it actually is. I'm going to walk you through it step by step. Here we go. 1. Find the forecast error for each period, which is the actual minus the forecast. That is the fourth column on our table over on the left, where part of it is yellow and part of it is blue. So find the forecast error for each period. Step 2. Calculate the percentage error by dividing the forecast error by the actual value, which gives you a decimal value. So y sub I, those are the actual values. Those are in the second column over on the left. So in the case of 2001, we would take 48, which is the forecast error, and then divide that by 1,499, which is the actual value. So what that gives us is the scale of the error, or the magnitude of the error relative to the actual value. And then we would do that for the next one. So in 2002, we would take 187 divided by 1,686, and that would give us a percentage error, an absolute percentage error of 11.09%. Then we do that all down the column. Then we multiply by 100. That actually gives us the percentage value. So the division gives us a decimal, multiplied by 100. That gives us the percentage value we see there in the last column. So at this point, we would have percentages in the last column, but some of them would be positive and some of them would be negative. Next, we take the absolute value of each percentage error, which of course just means making them all positive. That's why the final column in that table is APE, which is absolute percentage error. Then we sum the absolute percentage errors. So we take the sum of everything in that last column, and then we divide by the number of forecast errors we have there, so our observations. And when we do that, we get a MAPE of 3.59%. So if we take the mean or the average of all those percentages there in the final column, we have a MAPE of 3.59%. So what MAPE tells us is that on average, the forecasted values, which are there in the middle column, were off by approximately 3.59% from the actual values, which are there in the second column. So again, because this is a percentage, it's sort of standardized. So we could compare this time series to a different time series, maybe a different country, maybe taken at a different time, or we could compare it to something else entirely different. And because they are percentages, we could compare the two. This will also allow us to compare different forecast methods. So we've used a naive forecast only up to this point, but when we use other forecast methods, the MAPE makes comparing them easier, and therefore we can find the best one easier. So here is a graph of the absolute percentage errors. So this is the final column in that table we saw on the previous slide. We can see that the largest absolute percentage error was in 2002. And then as time went on, the absolute percentage errors decreased quite a bit. So here is the mean absolute percentage error, so 3.59%. So if we took all the error above that dotted line and then redistributed it to the ones below the dotted line, they would all be equal right across that dotted line. So 3.59% is our mean absolute percentage error. We can see that on the right, the absolute percentage errors are pretty small relative to the first part of the graph. Well, why is that? Remember that our time series sort of flattened out about 2/3 of the way into the series. So when that happened, we achieved pretty close to what's called stationarity, and the time series flattened out horizontal. And in the naive forecast, when that happens, the lines become very close together, and therefore the actual versus the forecast, because we're in stationarity, narrows. And that's why our percentage errors are small at this point in the graph. So here is our Nigeria GDP per capita forecast accuracy matrix. We've been building this out throughout this playlist. So the naive forecast is there in the top. That's the only forecast method we've learned up to this point. Then we learned about the mean absolute error, the root mean square error, and now MAPE, the MAPE. We can see that because it's a percentage, it's going to be more useful as we get into forecast method B, C, D, and E, and so on and so forth. So remember that in general, the goal is to minimize the forecast error, in this case a percentage, for the known time series. Then use that forecast method or methods to make forecasts for future unknown values. Not all forecasting and evaluation methods are appropriate or possible for data with certain characteristics, and actually MAPE is one of them. For example, data or errors that can have negative and/or values of 0. One of the downsides of MAPE is that if the actual value is 0, then we have division by 0 in MAPE, and we'll talk about that more as we go. Evaluation methods are sometimes in different units. So original units, like we see in the MAE and RMSC up here, scaled, percentages, and so on. So this is a percentage. We can compare across different methods using percentages. Therefore, comparisons of forecast error occur within a method or between methods that use the same unit or scale. So in this case, in this matrix, we would compare by the columns. So we would look at all the mean absolute errors across all the forecast methods. We would look at all the root mean square errors across 5 methods, the MAPE across 5 methods, and so on and so forth to pick the, quote, winner for that measure. And of course, it is very common for methods to disagree about which is the best method for forecasting. So for example, above, it might turn out that the naive forecast has the smallest value in the mean absolute error, so $76.55. When we do forecast methods B, C, D, and E, those might be larger, and therefore, in the MAE column, the naive forecast wins. In root mean square error, it might be, just for example, that forecast method D has the lowest value, and therefore it would win that column. And finally, for MAPE, forecast method B could end up having the lowest percentage, and therefore it would win that column. So they do not always agree when it comes to the best method, and then it's up to us as the analysts to decide which measure or measures we want to use. Okay, that wraps up this video on forecast accuracy, the mean absolute percentage error, or MAPE. I hope you found this helpful, so please stick around for future videos and time series. I thank you very much for your time and look forward to seeing you again in the next video. Take care and bye-bye.